In this question here, we have Ursula who wants to swim across a river. The river is 10 kilometers wide. She wants to end up 2 kilometers down the river. We want to know what angle she should take to end up in that place. Well, if there was no current to consider, we would simply determine this angle here, and it would be easy for us to tell the angle to the bank that she should take across. However, this question is more challenging because it tells us that there's a current moving 3 meters per second, and that Ursula has to somehow take that into account, as well as the fact that she can swim 9 meters per second. So she has to take all that into account to figure out what angle she should take off from the bank. So we draw ourselves a diagram like such. Here's Ursula's starting point, and this is her ending point. And using some pretty straightforward trigonometry, we see that this angle here is 11.3 degrees. Now, there's one of two ways we can go here. Let's focus first of all on assuming that when they say down the river, that she actually wants to end up in the direction with the current. Assuming that to be the case, then, we take this 11.3 degrees, we easily determine that this is 78.7 degrees, since it's a perpendicular angle here. And we draw our first triangle, noting that this has to be a 78.7 degree angle, and that her velocities, or her speeds, are 3 meters per second and 9 meters per second. Well, we're interested, this 9 meters per second represents Ursula's direction, and this 3 meters per second is the current, and we're interested in this angle right here, because we're interested in the angle that she takes from the bank, and the bank is parallel to the current. So in order to figure out this angle, though, we're going to have to figure out this angle first. So we say 3 over sine beta is equal to 9 over sine 78.7. And when we evaluate for beta, we see that beta is approximately 19.1 degrees. That's a 19.1 degree right there. So since this is 19.1 degrees and this is 78.7 degrees, we see that Ursula's angle should be approximately 82.2 degrees here, making 180 degrees overall. So in other words, if this is 3 meters per second, and this is 78.7, and this is 9 meters per second, this would need to be 82.2 degrees. So our first answer is that Ursula should swim into the current. This is the 3 meters per second current. She should swim into it at an angle of 82.2 degrees to the bank. However, it's possible that someone misspoke when they said down the river, and they were a little more casual with their language, and what they meant was down the river this way, in other words, against the current. Well, let's assume that the person misspoke, and we'll evaluate option 2. Let's assume that they want to actually end up way down here. If that's the case, then we see that we'd be talking about this being our triangle here, and this being 11.3 degrees. That would make this angle 101.3 degrees, as we have here. Well, drawing the same triangle that we had before, the analogous triangle for this situation, we see that this side length should be 3, and now this side length should be 9. Well, we set up a sine law the same way we did and solved for this version of beta. And when we do that, we see that beta is approximately 19.1 degrees. Now that makes sense because all of the values are the same as they were last time. But because this is 101.3 degrees, we have 19.1 plus 101.3, leaving us with 59.6 degrees. So if she wants to actually end up 2 kilometers against the current, then she's going to have to take off at a much greater angle into the current. So she's going to swim at 59.6 degrees to the bank, or in other words, more directly into the current as she did last time, to end up way down here. Now to repeat, I think this is the more correct option because down the river generally means with the current, but it's nice to know that we could answer it both ways in case the person misspoke.